Okay, we are going to walk through some examples on finding limits graphically. Before we begin, I want to remind you that there are three reasons for which a limit does not exist. So a limit does not exist when the limit from the left doesn't equal the limit from the right, when there is unbounded behavior at target value, and you should be thinking vertical asymptote would be an example of this. And then finally, a limit does not exist when there's oscillating behavior at the target value. Behavior. And so unless you have a vertical asymptote or unless you have unbounded behavior, vertical asymptote, or oscillating behavior, so other than 2 and 3, what you should be considering every single time you start to try and find a limit is, does the limit from the left equal the limit from the right? So we're going to go through some examples. You are welcome to print these notes off, or you're welcome to open them with Cami in Google Chrome, and you can just write on the sheet with me. So the first one, we have the limit as x approaches -2. So I'm going to first look at where the function is -2 on the graph, and then the limit from the left and the limit from the right. I will do the right in a different color so you can see that better. So the limit from the left is going to be green, highlighted. The limit from the right is going to be pink. And then we have to ask ourselves, are those approaching the same y value? And they are. They are both approaching the y value of 4, so that is our answer. All right, in the next example, for number 2, we're trying to find the limit of the function as x approaches 1. Well, the limit from the left is approaching a y value of 0. The limit from the right is approaching a y value of 1. Therefore, the limit at 1 does not exist. Now, something that sometimes trips students up is if I am saying the limit from the left, I'm headed towards the right. And that sometimes trips students up for some reason. So that's why I'm drawing those arrows as I'm saying it to hopefully help give you a visual. So in number 3, we are trying to find the limit as x approaches 3. So from the left, the y value is approaching 0. From the right, the y value is approaching 0. That means the limit is 0. And sometimes this is difficult for students to understand because since there's a hole there, students want to say does not exist. Now you could say that the limit, or rather that the y value for f of x at x equals 3 is undefined, or f of 3 is undefined, but that does not affect the limit. The limit is still 0. All right, in number 4, we have 2 different questions. The first is the limit as x approaches 1. Well, hopefully you notice that at 1, there is a vertical asymptote. Those numbers are a little bit hard to see, but that's at 1. Therefore, the limit does not exist at 1. However, at -1, we have a very similar situation as we did in question number 3. Even though there is a hole at -1 and the y value is undefined, from the left and from the right, the function is still approaching a y value of 2. And after that, number 5, we are trying to find the limit as x approaches 2 of f of x. Well, from the right, there is a limit. So from the right, it's approaching a y value of 3. But from the left, there's not a left side. Therefore, this limit doesn't exist because the limit from the left is not the same as the limit from the right. In number 6, we want the limit as x approaches -1. So here's -1. So I want this y value, watch these go by a half. So the limit from the left and the limit from the right are both 1. And then f of 2, this is looking for where's the solid dot at 2, the solid point. So the solid point would be here, and that is a y value of 3. All right, so now we have a big giant graph, and I actually have a couple copies of it somewhere on here so I can pull it up because it's kind of hard to see on my tablet. Whoops. Let's see if I can do this. There we go. That's what I want. So it lets me kind of pull it around so that way you guys can see where I'm at any certain point. All right. So we first want to find the limit as x approaches -2 from the left. Now, something we should probably chat about really quickly is if a limit does not exist because the limits from the left and the right are not the same, the limit from the left and the right can still exist. So for instance, the limit from the left could be 3, the limit from the right could be 5, but the limit wouldn't exist at that target value. So now we have the limit as x approaches -2 from the left. Remember that negative sign right here means from the left. So the limit as x approaches -2 from the left would be here, and that's approaching a y value of -1. From the right side of -2, it is approaching a y value of 5. Therefore, the limit at -2 does not exist because those are not the same number. And then we have the limit as x approaches -1. So -1 is right here. Now I kind of wrote on top of there, so I'm going to erase that. So the limit from the left of -1 would be right here. It's a y value of 4. The limit from the right of -1 is also 4. So coming from the right, I'm looking there. So even though there's a hole there, because the limits from the left and the right are the same, that tells us the limit as x approaches -1 is 4. Now the next one I'm going to do on the next graph. So the limit as x approaches 2 from the left. Well, the limit as x approaches 2 from the left is 4. The limit as x approaches 2 from the right. Now, and I put this graph this way on purpose because as you come in from the right, do you see how it's increasing and it's just going up and up and up and up? Sometimes, more often than in pre-calc, you will have a vertical asymptote at a value and it's not clearly shown. And that's actually what's happening here. So the limit as x approaches 2 from the right is actually infinity. Now, this is tricky because we know that a limit cannot equal, or anything can't equal infinity because infinity is not a number. However, to make it shorter of what we have to write, that's just the notation we use. And what this really says is the limit as x approaches 2 from the right of f of x does not exist but increases without bound. So that's just kind of a shorter way that we choose to write that. You would never write that the limit at a specific target value when it's not from the left or right equals infinity or negative infinity. You could always write does not exist. Now, there are cases like if you had a function, let's say that looks like this, and we'll look at these at some point, let's say, and both at whatever your target value, let's call it C. Let's say they both approach infinity on both sides. If you wrote infinity, it would be accepted. That's just so like if you wrote the limit as x approaches C of f of x is infinity, that's just saying the limit from the left and the right are both infinity. But does not exist would be acceptable as well. So in this case, obviously those are not the same, so the limit as x approaches 2 does not exist. The next 3 questions go together as well. So it says, what's the limit as x approaches 0 from the left? Well, from the left, it's approaching a y value of 0. From the right, a y value of 0. And since those are the same, the limit as x approaches 0 is 0. And now we have 4 questions. We want to find f of -2, f of -1, f of 0, and f of 2. And that's just asking for the y values at those points. So I'm going to take all that back off my graph. So f of -2. Again, you're looking for the solid point. So that would be 5. F of -1. Again, you're looking for the solid point. Would be 2. F of 0 would be 0. And then f of 2, you have a hole or a vertical asymptote. You can think of it either way. So this is a undefined. So limits, we could say, do not exist, while y values, so like f of some number, can be undefined if it doesn't have a defined y value. I will tell you that sometimes your book will put, or WebAssign as well, will put does not exist for a case of f of 2, and that is not correct notation. It's something that it accepts, but I would not consider it to be correct. All right, if you have questions, please shoot me an email. I hope you are having a good day.